Welcome, everyone. I hope you enjoyed our little reception gathering, which just finished, with some flavor of Brazilian music and some drinks as well. Hope you didn't drink too much because we have an awesome session coming up now. Thank you for joining us for the second keynote of the conference. This opens officially day 2 of RecSys 2020. My name is Rodrygo Santos. I'm the chair of this session. Just before we get started, if you have any questions for our speaker, please post them on the Huva Q&A interface, and I'll be happy to relay them to the speaker after the talk. Our talk today is on bias on search and recommender systems. It's my honor to introduce Ricardo Baeza-Yates. Ricardo is the director of data science programs at Northeastern University in the US. I believe he also holds a position at the University of Chile and maybe still a position in Pompeu Fabra in Spain, if I'm not mistaken.
Yes.
Ricardo is a member of several advisory boards and councils in national governments and also computing societies. In particular, he's a fellow of the ACM since 2009 and of the IEEE since 2011. He's a founding member of the Chilean Academy of Engineering. In 2018, he obtained the Spanish National Award in Applied Computer Science, among many other awards and distinctions. Ricardo holds a PhD in computer science from the University of Waterloo in Canada. He's one of the key references in web search and data mining, information retrieval, data science and algorithms in general. He's arguably one of the most well-known figures in the Latin American computer science community. And I would say unarguably one of the most well-connected ones. He's a close friend to many of my colleagues here at UFMG. I've known him personally for a while. It's my pleasure to introduce his keynote today. And I hope you enjoy it. Ricardo, over to you.
Thank you, Rodrygo, for the kind invitation to give this keynote, and congratulations on the success that you have having so far with so many people registered. So let me share my screen. So I wish we could be here in Rio de Janeiro, one of my favorite cities in the world. I mean, the geography is spectacular. Part of this talk appeared in Communication of ACM in June of 2018, if you want to read more details. But after saw this nice picture of Rio in the website, when I was preparing the talk, really my view was something like this. So not too different in color, but I guess not as nice in pollution. So before I start, let me go a very high level view of maybe the world where I have done research. So I have done mainly research in information retrieval, in data mining, a little bit in recommender systems, and also in databases. And here is one possible taxonomy for this world. So you can split data in unstructured and structured. Let's leave semi-structure in the middle. And you can say that the query could be explicit, and then we are in search or let's say relational databases, implicit, and then we have the context, we have recommender systems, or could be completely unknown, if that's the case of data mining, where we find the answer, and then we come up with what is the right question. And you can see that basically many of these things could be called databases, but I guess databases, because of historical reasons, at the end was for relational databases, and only the last year this has been expanded. And maybe a little bit of history will be good here, because many people don't know this. So this is the first paper on relational databases, one of the landmarks by Code. Was published in Communication of ACM in 1970, so that's 50 years ago. And you can say that today, depending on the complexity of the problem and the data volume, databases is migrating to other type of data, to non-relational models, non-SQL, for example, and so on. So they are getting closer to data mining, which I would say is more complex than search. And I was trying to think where I would put recommender systems here, but I guess it's everywhere. So it depends on the complexity of your system and the volume of it. This will be closer to one of these three. See? And if you haven't noticed, something very important in this paper is the label. So the label of the first database paper is information retrieval. And maybe this may be a surprise for you. Yeah, because information retrieval has 70 years. The term was coined in 1950, so much earlier than databases existed. And of course, because that's one of the main purposes of a computer is to search for information. And then, of course, you will ask, well, what about data mining? What about recommender system? Well, they started more or less at the same time and about 30 years ago. So maybe we can say that this is a interesting year for this, all these fields because they are having important anniversaries. So I will assume that you know what is bias. So I have a lot of material that I want to present, so I will skip this. But basically, you have a statistical biases, which is a systematic deviation from a prior unknown distribution. Then you have all the cultural biases that you get in your bringing, even in your language. And then the worst one, and Phil mentioned one of them yesterday, cognitive bias. And this one may be one of the worst, is confirmation bias. We see something that we believe, and then it's true. And this is one of the patterns of this information that Phil talked yesterday. And there are more than 100 of them, and we'll not cover all of them, but these are the three ones, and we will get back to this later. So the main reason of my interest on this talk is the impact of bias in what we do in search and recommender systems. And as you saw, the only difference between search and recommender system is the query. So in one case, it's the context. Sometimes it's also in the search, so you get recommendations after the search. So there's not much different in those two systems. In some sense, could be the same. So most web systems and most systems in general are optimized by using implicit user feedback. And we will see that the problem is that if we're recommending things, the system is partly writing their own future. So we will see later, and we'll try to convince you that it's not only that we have echo chambers for people, but also we have chambers for recommender systems. And I want that to be one of the main results of this presentation. And very important, clicks can only be done on things that are shown to us. So we will get back to this, and we will get back to exposure bias, which for me today is the main bias that you find in this kind of systems. And sometimes these systems basically fight themselves because they are learning from behavior of people, but some of this behavior may be machines, like the bots that Phil talked yesterday. And then we are not really learning human behavior, so sometimes we're learning also machine behavior, and that means algorithms behavior. For example, the typical case is the clash between user experience and monetization. So sometimes you monetize more, but the user experience is hurt, and vice versa. And maybe these are two teams in the same company fighting each other if you don't have a common optimization function for the system. So the hypothesis here, and it's a fact, is that all observational human data has bias. So all the data that comes from interaction has bias. Of course, if you do an experiment with human, maybe we can control some of the factors, but you shouldn't do experiments with humans. So this will be a wild system. So I will mention here some possible cultural biases. I will not read them. Some of them are very well studied. Then you have statistical biases in the gathering process, in the sampling processes, in validity of the data, in noise, in spam, completeness. And then you have all these 100 cognitive biases that I mentioned, but we cannot put all of them, so we will have only one, and we'll call it self-selection. So it's what you do when you interact with one of these systems. A lot of people have done work on the major social biases that we have today, like gender, race, sexual orientation, and so on. But if you take, say, Twitter data, Twitter already has these 6 types of biases. So it's more males, more young people, more more educated people, more rich people, and so on. And what I want to try to do here is that to cover all possible biases, not only the ones that are most negative and are on the focus of news, but try to give an overall view of all the biases in these systems. So we have to start with a non-technical question that we should ask ourselves every day, and we still don't. So all data is biased, so all our algorithms are using biased data. So the question is, should an algorithm be worried about that? Should an algorithm be neutral with regards to the bias, or should be fair and do something about it? So most of the time, we don't worry about this problem, and we get the same bias, if we're lucky. Sometimes even the bias is magnified by our systems, and we will get back to that. So what is being fair? That's a hard question already. It's not a computer science question, it's a social question. And then you need to bring, for example, an ethicist or a sociologist to have the difference. But here is a typical three cases that you may care about fairness. Is equality, equity, when you do an affirmative action, and then, for example, the kid can see the football game or soccer game. And then justice is getting rid of the problem, but usually justice takes a long time and it's much harder because bias is in society. So the question has the typical answer when you have a hard question is, well, not always. It depends on what the algorithm is doing. For example, maybe bias is not relevant for the problem we're solving. Particularly, for example, we're trying to find bias, please skip it. But if you harm people in any way, like in a bank or government or hiring people, then yes, you need to take care of this question. And every day you see in the news one more problem by algorithms that didn't take care of this. So how we solve this problem? This will be a completely different talk, but I will mention some examples later. You can debias the input, you can tune the algorithm, or you can debias the output. They have different difficulty, but of course, if you debias the output, you already lost a lot of information. So the main goal of this talk is to be aware of all the possible biases in these systems. So more than 3 years ago, the US Policy Committee of ACM did a statement on algorithm transparency and accountability. And many other institutions have done similar things. And these are the 7 properties that an algorithm should fulfill. So this talk is about awareness. But you have things like accountability, data provenance, explanation, very important in AI. And one problem today is that most algorithms don't fulfill these 7 properties. And the question is, should we change all the way we do software with design algorithms to fulfill this? Probably the answer is yes, or otherwise insurance companies will do it. And I guess the world will be much worse. And here I would like to remember that systems do not need to be perfect. They just need to be better than us. So maybe self-driving cars will kill some people. Yes, for sure, already happened. But I'm sure will be much less than people that drive and drink, that look at their cell phone or do other things that they shouldn't do in a car. So long time ago, so even more than 20 years ago, the first people looked at bias in computer systems. And although many people think that the main problem is data, and that's why we have this garbage in, garbage out, and even there are Twitter discussions with very famous AI people saying that bias is in data. Well, I will show you that today's bias is not only in data. And for me, the most dangerous bias is not in data, it's in us. It's in the developers of the systems. So there were some early papers in '95. Then there was a seminal paper that I think all people should read it by Friedman and Nissenbaum. And this has many important implications in machine learning, because we always assume, like implicitly, that things behave well. That, for example, the data is the same everywhere in the problem space. That the error is uniform. If you analyze the error, that's another thing that we should do more. Do error analysis. do sensitivity analysis. And part of the problem may come from the data sample methodology, and I will talk a little bit about that. So this is the issue with prediction error in artificial intelligence, in machine learning. Typically, will grow with the complexity, and the only way that will grow nicely is that you put more data, because if you don't put more data, this will grow maybe exponentially. So, of course, this depends on the problem, but this is the problem we're dealing with. So more complex, we need more data, and a lot more, and you can see that in deep learning, to get to very good prediction error. So let's start then with the cycle of bias, and I will use the web, which is what we use every day, and most systems are today in the web, to show all the biases here. So the first one is data bias, right? The main one. And in search and recommender system, we have web spam or other kinds of spam. And I can give another talk about this, so I will skip this. But of course, it's a major problem. But we have studied and we have done a lot of research on how to handle this. But I want to give some examples of more subtle cases of data bias. So for example, this work we did with Carlos Castillo and Vicente Lopez a long time ago for the Web of Spain. And here we compare the exports in thousands of dollars in the vertical axis and the number of linked domains from the Web of Spain to other countries or to other domains in the horizontal axis. You will see that there are some outliers. So for example, like TK, FM that we use for radio. So these are outliers, these are not real countries, because these are domains that were kind of sold for other purposes, so they are not really for commerce. But if you see the rest, there's a very high correlation between links and economy. And we did this with 5 different countries later with Carlos, and you see that more developed the country, larger the correlation, from the UK to Brazil and Chile. So there's a very strong indication that there is some causality, although it's very hard to prove causality. Also, you can have cultural bias in content. So for example, you will find the typical power law from SIPS, the minimal effort law, in things like the average size of pages in websites. But then you have also that for small pages, we have another law I call the shame law that basically fights the minimal effort law until you give up and then you stop doing a larger page. And of course, you finish when you have more or less one page. And this happens, I will skip all the example, but in many other things. For example, for images, the average is more or less 3. In South Korea, it's very large, 12. In Spain was very small at that time. But you see that, again, you see this cultural bias coming from the shame law and the minimal effort law. And the numbers are different, but the lines are the same. Very quickly, linguistic bias also in data. For example, this company, Language Connect, claims that if you take the top 1 million websites, most of them are in English. I cannot audit that, so I don't have access to that list, but I think this is roughly true. And then the question is, what is the reference value? What should be? And of course, we can take all the people that live on Earth and use their native language. Here, English will be less than 10%. Or we can have a different reference, like the top 10 languages used on internet today. And here, English is 25%, but still, so there's a large bias. But someone may say, well, but you're comparing users. Why not to compare content that is valid? And then we can use, okay, the content of the web. And their estimation that 27% are in English. And then still, we have bias to the English language in what will be the best content. And of course, this quality bias will be important, so we'll get back to that later. But this is one of the problems of bias. What is the right reference value? Very quickly, if you do a news recommendation system, many people have done that. Well, most of the news will come from the capital. These are news in Chile, and you can see that the top is in the capital. So one of my former PhD students tried this, Eduardo, and proved in the wild that, of course, people prefer systems that bias the news to their location instead of basically biasing the news to the collection, which is biased to the capital. And this happens in any country. Very famous paper 4 years ago in Europe, gender bias in content. You use word embeddings from web news, and then you get these she-he analogies. Most of them are stereotypes, like if she's a nurse, he's a surgeon, or if she's a diva, and you know there's some negative connotations to that, he's a superstar. So after seeing this work, I said, well, most journalists in the US must be men. And yes, they're mostly men, but I found a surprise that at college, most of them are women. So there's a more structural problem here of how to get a job in journalism, but this is a problem that is outside the scope of this paper, sort of this presentation. So, of the paper too. So my best example and the last one for data also comes from Eduardo's thesis, PhD that he did with me in Pompeu Fabra in Barcelona, is biographies of women in Wikipedia. And you see that they are improving. So now we're getting close to 25%. Of course, we're still far from 50. And you see that something happened in the French Revolution, I guess, and things started to change. So you can say, okay, this is nothing new here. This is the systemic gender bias that we already know and they were fighting today. But the truth is that here there is a much bigger bias that will be obvious after I tell you. Most editors in Wikipedia are men. So only, for example, 11% of women in biographies, but by the way, this is partial information because many women prefer not to give their gender to avoid any harassing. And maybe this number is 15%, but it still is biased. So let's go to engagement or activity bias. And this was mentioned yesterday by Phil. So this is the bias that all of us as a group create by using these systems and comes from the power law. So this is the power law where we have actions and we have people, and most people do little. In fact, we will see that most people do nothing if we take, say, 1 day of time, and very few people do a lot of things. And I remind you of a very important paper that was done at Yahoo Labs in 2010, that basically all the people is in the long tail. So we are all partly at some point do many things, at another point we do less things, and we are all there in the special things, like different queries, different contexts. Also, we are all there. So we have like 2 different states. We are doing what everyone else is doing, or we are doing things that only are important to us. So one of the main effects of this engagement bias is popularity bias in recommender systems. And of course, there will be many popular items, and we have this, again, this thing. And by the way, these slides are courtesy of Pablo Castells. And you can solve this problem by, for example, using novelty. This will be one way to solve the problem. And maybe if that's enough, well, the problem is that it's not enough because the ratings that are missing are not at random. So basically, the ratings that are missing are in the long tail, right? And of course, the judgments that are missing non-randomly because we are using this bias distribution. And there's a lot of work on RecSys on that. There's some reference here. So we are basically in a self-fulfilling prophecy. We can do things like compute the average precision at K, and you will see that this will have a problem. And worse, we have the user system reinforcement loop, and it's even more difficult to solve this, and I will talk later about that. So this is a problem for IR evaluation methodology. So this is also similar to the search world, and Pablo and his colleagues have a very interesting paper on using IR measures on recommended systems and what are the biases that you find there. So for example, one problem in search is to how many queries is document relevant. And you see here 2 different collections, one coming from recommended systems, one coming from IR check, and you see they are quite different. And if you want to answer the question, we have a paper with Paolo and Flavio, where we show, for example, that with 1% of the URL, much less than 1% of the URL, you can answer 25% of the queries. But of course, you need to know in advance which are those URLs. So we have this distribution where we have people that are very different from each other, people that are partly similar, and people that are identical to each other. And the distributions, of course, will be completely different. Of course, the real case is the middle, and that's the hardest one. The left is also could be even more harder, but it's not realistic. So we need to get rid of popularity bias, and there are many papers. I'm sure there are papers in this conference about popularity bias, and there are papers coming to every major web search conference too. And here are some references, the things that you can do, changing the metrics, changing the algorithms. Even one recommender system work in 2018 got the best paper award in the search conference. So that's why I'm saying these two worlds are being closer and closer, because we're using the same kind of ranking and the same kind of, let's say, debiasing techniques and so on. So, but this activity bias, this engagement bias also affects content, and this is more complicated. So this is the work of other of my PhD students, Diego, that now works at the Wikimedia Foundation. So most users are passive. We don't know how many, because only each system knows how many people don't do anything. Like only Twitter will know how many are not doing something in a segment of time. But let's say it's roughly 90%. I will tell you why later. And then we can ask the question, and this was something that was very important to me, it's like a democracy of content. What is the percentage of active users that produce 50% of the content? And we look at 4 different sets of data. So a small one from Facebook, where we found that 7% of the people did half of the post. So this means this circle, 7% did one half, the 93% did the other half. Then we look at the large collection of Amazon, part of the Amazon reviews of Stanford, and there we found that 4% of the people did half of the reviews. I really believe that this result was not right, and Diego revised his code several times, I think. And then I said, okay, if this is true, then people must be getting paid for this. These are not for free. And I don't know if Amazon ever read the paper, but 1 month later, Amazon started a campaign to sue all the fake reviewers. And this continue even up to this year. So here is one article just published like 2 weeks ago about the problem with fake reviews. So be careful, I will get back to that. Social bias can be very dangerous. So this is social bias. It's what we see from other people, and that may affect our decisions. We look with Diego at the quality of content. So we found that, for example, text entropy was a good proxy of the helpfulness of the reviews, basically the stars. And the 4% based on activity went down to 2.5% if we look at quality of the content. So basically 2.5% of the people did half of the best reviews. So this is shows maybe, again, that they were being paid. We also tried with Twitter, and in Twitter we found that a bit more than 2% of the people did half of the tweets. Not surprising, I guess the ego is the main force behind this. And then we look at all the Wikipedia data, which is public, and about 2,000 people did the first half of English Wikipedia, where they were paid. And maybe because of that reason, we have Wikipedia today, because no one wants to contribute to something that is empty, and at least needs to be half full if you are an optimist. And why 90%? Because the Nielsen in 2006 did this rule of the 99-1 rule of internet participation. So basically 90% were just watching, 9% were interacting with the 1% that were doing things. But this result here shows that it's even worse. So the 1% is less than 1%. Is, if you look at the 50% of the content, it's even smaller. There's also a problem of attention bias in the end of the long tail. and something I also wanted to find out, and Diego also worked on this, and this is an upper bound and lower bound. So basically 31% of the articles that change in 1 month in Wikipedia, no one look at them in the next month. And worse, we found that more than 1% of the tweets were done by people that didn't have any followers. So this is like going to the Atacama Desert in the north of Chile and screaming. So yeah, it's maybe cathartic, but no one is listening to you. So there's a lot of content that no one ever sees. So this is lack of attention, and it's partly because of information overload, a topic that Phil also covered yesterday. So let's get to the middle of the circle. The most important one is search or recommender system, the algorithms that we use. And here we have several problems. We have a sampling size bias, for example, typical problem, or maybe we have an algorithm bias. And when I say algorithm, it's a bias that comes from the algorithm, not from the data. Some people, when they say algorithmic bias, they cover everything, and I think this is a mistake. We should use only the word that is the source of the bias. So algorithm bias is only something that comes from the algorithm. So sample size. Well, statistic books have also some bias. For example, they are biased to the uniform distribution, and they are biased to p equal 1/2. I still haven't found an implication for that. That doesn't happen in reality. For example, if we're working in the web, we are working with very low probabilities of a click, for example. Probability of clicking in a result, probability of clicking in an ad, and probability of clicking in a recommendation, and so on. And maybe these are news for you, but the typical error formula diverges in p equals 0. So here you can see it. So you have to use other things like the aggressive cool interval to basically do the right sample size. Here I give a very simple example where I show that the size is the sample size should be more than double, more than 2,000 instead of 900, and I'm using a very bad confidence interval because these things grow much faster than linear. So a smaller probability, worse the mistake if you're using just the standard error formula. And the same happens when you use the standard sampling algorithm, the one that uses the distribution, because if you have very skewed distribution, even if you use the right sampling formula, you get the wrong distribution. Here you see these are queries from a search engine, and you see that if you go down to a sample of 1,000, then you don't get the right distribution. You get a different tail and you get a different slope. So then you need to use stratified sampling, and you have to do something different in the tail. You can look at my paper in 2015 in SIGIR, but then you get exactly the same distribution. Here is a tiny distribution of less than 200 queries that are coming for more than 100,000 queries, and you see exactly the same shape. Okay, so there are other biases. One important that I will not be able to talk, but you can see the work of Lipani, is accessibility bias. So basically, can you retrieve the document? And there are many reasons of why you cannot retrieve a document, and this is also important in search. But as we're focusing on recommender system, I will skip this, but you have it here if you want to read it later. So let's go to an extreme example of algorithmic bias. I still haven't found a better one. So maybe some people have seen this, but basically, let's say you have a system where you can upload images and then you can tag them, you can put labels. So I upload this image from London, I put London Eye and Thames, and because you are you allow a recommender system, then you build a recommender tagging system that uses, of course, the filtering and co-occurrences of tags, and works fine, right? You will click in London, in England, in the South Bank, and so on, bridge. So it looks great. What is the problem with this? The problem with this system is that people will use it. Is that the problem? Yes, because if people will use it next time, they will write only London Eye. And if they know that we are using deep learning, they will not write anything. They say, okay, let's the system come up with the tags, and I will just click on the right ones. What's the problem? Well, you don't get any new tags coming from people. So the taxonomy is basically stuck, And the system cannot learn anything else. You need data from people to learn. So please don't help people in many cases, like in a autonomy. So this forbidden, but many people do it. I can mention some very famous web systems that did it and they are gone. So where is the worst part of algorithmic bias? Well, it's in the interaction. But here we cannot blame only the algorithm, we have to also to blame the people. So this is the union of the cognitive biases of the users and the algorithmic bias that comes in the interaction. And the interaction, I will do a small experiment. So I mean this. So I don't know if anyone was able to read what was written at the bottom of the slide, but many people never read it because they're not that fast. So you may read it later again. So this is what I'm saying. People can be manipulated by the user interface. And for example, in the Western world, we always will look to the top left corner because we read that way. And here, for example, this is a bias query, and you can guess the site. So how many biases we have in this interface? Well, the first one and the main one is what is called exposure or presentation bias. You can only click in things that the system chose to you. So this is like an iceberg. There are millions of things that you cannot click, and you can only click not in the top of the iceberg, you can only click in the tip of the iceberg, because really there are many more below, more than in an iceberg. Then we have things like position bias, like as I said, the top left corner may get more views, but then you have ranking bias. People click more on the first result only because it's in the first result. And well, this is part of the cognitive bias of people. It's not only the fault of the system because you want to rank things, right? And then you have social bias, already mentioned this. So basically, if you see 4 stars or 5 stars, maybe you will buy this product because it has many good reviews, but remember, they may be fake. So be careful, look at many, many reviews before using the social bias. So many times it's better to use your own judgment, like Phil said yesterday too. So one problem with this interaction is that they are all depending on themselves. So basically this is a dependency chain like this one, and there's almost no research on this. This is part of my paper 2 years ago, and there's very few research on how these things interact with each other, and that's why it's so different, so difficult to even analyze using A/B testing. And of course, all the left is a problem that comes from the system, but all the right is a problem of come up from the user. So the user is the one that is clicking the top results, that is moving the mouse, or for example, scrolling or not. Some examples from ranking bias. So you see this is a heat map using eye tracking software, and you see how things have shifted from 2015 to 2014. These are results from Mediative, this company. And you will see that after universal search started, you have other types of results, then people is looking at basically other places. And of course, you get this kind of distribution. So for example, here you see the click-through rate, real distribution, and navigational queries like 15% of them. So this is, again, the minimal effort issue with people using search to navigate. But even if you take away navigational queries, which is about 15% in mobile, then you will see that still you have ranking bias. And also here you see an example of interaction bias. Some engineer thought that you need to have 10 by 10 results in a system, and luckily in mobile we don't have that restriction. These results are from desktop. And then if we plot this, you will get that we have in a log-log graph different distributions, but we want to find the real click distribution, which will be the one that will not be really ranked. And in Yahoo Labs, we did 3 different papers on this. The last one was the best paper award in Wisdom 2010. Of course, all search engines use some kind of debiasing for clicks. And then also you can use learning to rank with bias. The first seminal paper was by Sols and Joachims in 2017, also got the best paper awards. I have some work with Carlos Castillo and his students on fair rankings. But I wanted to put this because this is one good example of when you can debias the input, you can tune the algorithm, or you can debias the output. And of course, one of the issues is important is fair ranking. I think I'm running out of time, so we'll skip this, but there are many definitions for fair ranking. This is one of the simplest ones. So let's go to the last part. That's what I call the second order bias. It's what people do with the data they get from the interaction with the system. And the first example will be data that goes back to the web. And this is another work, maybe my first work on bias from a Brazilian, the first student that the second student I co-directed with Nivea Sibiani. So let's say you're writing a new page for your blog. There was an early paper that was Phil and his colleagues that said that basically the bias was mitigated by this process of the web, but really we showed the opposite in this study. So let's say you take 3 pieces of text that you like, and these are biased to the ranking, and then we put them in a web page. Of course, you will link back to the page that you're using because you are not doing plagiarism. You will put the name of the author and you will put quotes. So these 3 things are the difference between plagiarism and research, right? And here you will feel some shame, the shame effect, because there's nothing yours. So you put part of your content and this will be like a mashup of other blogs. This is your opinion based on others. And of course, now the ego comes and you put your name on the top. And then you publish this back in the web. But what is the problem with this? It's not only biased to the ranking of the results, it's also biased to the ranking function that the search engine is using. So basically, putting back this into the web, you are reinforcing the system, and basically you are creating more redundancy, semantic redundancy, you are amplifying the bias of the ranking, whatever it was of that search engine. And this was basically, we found this following the trace of every page. So we call it the genealogical trees of the web. And we published in 2008 in the web conference. So the last case for feedback loop bias is basically when we use user data as feedback. So this is the relevance feedback loop that goes back. So the first problem, and this was mentioned also briefly in an answer from Phil, personalization. So basically, we can do very good personalization for people that have a lot of data, but not for people that have less data. But even if I know Rodrygo for a long time ago, and I can show you exactly what he likes, I will never be able to show something new that he doesn't know because it's not in the data, and that he would like if he will know it. So it's like the Truman Show. When you know you're in a bubble, you need to get out of the bubble. Most people, some people don't want to get out of their bubble. But in search and recommender system, we have used things like diversity, novelty, already mentioned, serendipity. And I would like a fourth option that is not available, my dark side. I want to see, for example, if I'm watching news, what are the most different news that people are watching, not because I want to see those news, only because I want to see the size of the universe, how far I from other people. I think today we believe that we're very close to people, in many cases we are not. And that's why we have polarization, and something that already Phil talked yesterday. So how much exploration we need to do to counteract exposure bias? Let's go there. So we have the echo chambers in systems, as I mentioned earlier. Sorry for the typo, just found the typo there. So for users, we have the filter bubbles, and you have digital feedback loops like the YouTube autoplay, and these are well known. But for system also, they are true. So you have short-term grid optimization. The system is partly writing their own future, as I said before. So you get a partial knowledge of the world. You never know the world completely. And this has very important implications also in revenue. So the system itself is also in a bubble. You can think that the system is in the bubble that is the union of all the bubbles of people. And interesting, last year there was a nice paper that showed that there are users' echo chambers. This was an interesting model using real data. And you see that, for example, more you know, more in the bubble. So basically, in the Oracle, if the Oracle knows everything about you, they will put you in a bubble because the Oracle doesn't want you to live outside the bubble. And so this paper shows this. However, there's an echo chamber, as I said, in the recommender system. So if you have short-term grid optimization, like most companies do, you have a partial knowledge of the world. How fast your world is changing? Can you really predict that change well? And of course, the long-term revenue optimization is not achieved. And if you know better your world, you will know better what to sell. This is the reason that many of the people here in the audience did a PhD. We afford to have a lower salary for some years because we knew that we'll try to optimize the long term. Why systems don't do that, do the same? Also because this has a disparate impact. You have unfair e-commerce, unfair information markets because you are hurting the players in the long tail. Can we do better? Of course, we can always do better if we want to. For example, if the amount of new traffic is enough to do good exploration, to basically predict well, for example, the click-through rate of a new item or the changes of behavior of people, you can do that. So basically you have this formula that the new traffic should basically be or equal to the traffic you need to approximate well the new things in the world. And this, I think, is a fundamental formula for recommender systems. It's not published, but I think this is very important. So otherwise, we will live in a suboptimal solution. And we are doing research on this with the Giovanni Del Nevo. These are unpublished results, but I can give you a glimpse. So we are trying to do a counterfactual approach to CTR prediction. So if we know what we want to find out, we can even compute the revenue of the system. And this is coming from real data. So we try many exploration algorithms with different amounts of exploration to find what was the best to basically, if you have enough traffic, get to the right point. And these are early results that, for example, this is the revenue. If the Oracle can get 100% of the revenue, then X3, a new exploration algorithm, it was the best one, 72%. UCB is 67%. Epsilon Greedy was 62%. And Thompson was really bad. Not too far from random, there was 2%. So I guess you shouldn't use it. We knew that, but still use a lot because it's the simplest one. And to finish, I think I have to touch on the problems of fairness and ethics. So because consumers and long-tail players are discriminated, we need to worry about this. And again, we have the massive effect. Rich get richer, poor get poorer. Unfair markets are unhealthy. And of course, this means that we'll never be stable in the long term. So also, this is a weakness. If you have a platform, it's unfair, a better platform can come in the future and do better than you. And this is not new. For example, you have all the problem of antitrust that I guess started with a seminal paper from Lina Khan in 2017 about Amazon. But there's discussions today that are more political than technical on other companies like Apple and Google. But in the case of recommender system, one very important problem is, should marketplaces sell in their own marketplace? And all the big marketplaces in the world, e-commerce, do this. So they sell their own products. This is not new, supermarkets do it today, but in e-commerce it's very different. You will see why. Well, there's a very interesting paper recently, just published, that says, yes, they should be able, that's better than ban that, but with regulations. For example, the main regulation is, I guess, is for innovation. If a third party innovates, can the marketplace copy that innovation and basically kill the small company? I think that's not ethical, shouldn't happen. So this is important regulation that maybe we need in e-commerce. And the reason is because there is a asymmetry of data. So basically, the marketplace knows everything about everything, and the other players don't. And as I said, it's not new, but gets amplified in e-commerce. So fair markets could do better revenue-wise. I hope I can convince you, and we should work on that way. So we should work only on fair system, and there are many papers that are exploring now fairness trade-offs in recommender systems. And here I mentioned one from CIKM 2018 that was, I think, one of the most interesting I found in the last years. So to end, we should look at our professional biases. So this comes in the problem. For example, why we're obsessed with big data and deep learning while all companies in the world have small data. And these are frequent, more frequent, and harder. So please, if you're interested in this, try to look at small data. Health needs more small data, and other major social problems need more to look in small data, not only in internet data. Do a system depends on the people that do create them? For example, a system from women will be different from a system from men? I believe will be. No one has done the experiment, but there's a similar experiment that was done with the data analytics, 2015, amazing results. The diversity of how people do things. Yes, systems are different, depends on their creators. And evaluation, well, choose the right experiment, choose the right test data, choose the right metrics, choose the right baseline. The first thing that reviewer will look, and I suggest to look at Julio Gonzalo's talk last year in his ESSIR about evaluation in search and recommender systems. And what we can do, and then I'm ending. Data, well, we need to take care of these problems. You can read this later. Interaction, make sure the user is aware of the biases. Tell the user, give the user more control. We need to not assume that the user is basically stupid. In the design implementation, you don't want biases. Contest every step of the process. And in evaluation, it's very simple. Do not fool yourself. Don't do anything of the I said in the previous slide. So the final messages, please be aware of your own biases. The bias starts by you. So for example, every time you say something that is gender or racially biased, try to be aware. Try to stop the vicious bias cycle. That means don't use minimal effort. Do everything by yourself. Think. And we should be fair. I hope I convinced you that we should be fair. And there are plenty of open research problems in this area. And if you consider small data, even more, because it's harder when you're working with 300 patients, things are much harder. So thank you, and I'm ready for questions. And I can take also bias questions, but then you will get bias answers.
Thank you so much, Ricardo. That was a very interesting talk, and I generated lots of discussions and questions in Whova. I can see them. I tried to manually curate some of them to avoid biases, but I think I failed miserably. So let me start with the most voted question by Dennis Parra, which is perhaps also influenced by Dennis's own popularity bias in the community. The question is, for many people, it may sound that all biases are negative, but it turns out that we need bias to learn from data. Given this, is there a clear distinction between good versus bad biases?
That's a very good question. Bias in principle is not a negative. So bias could be positive too. We have affirmative actions that are kind of positive bias. I had a slide that showed that the web works thanks to bias, and that was a positive slide, but I had to take it out because it was too long. But basically, this is another problem. When we mention bias, we have a bias and we think it's negative, but no. I mean, we need bias in data to do interesting things. I mean, imagine if all data were like a random noise, you cannot do anything. So we need bias. The problem is that basically we are only focusing on the negative bias because that is the one that affects our society. So it's sad, but all the news will be about negative bias, and sometimes you see some affirmative actions, and I can give you many examples of very nice positive bias that no one talks about because it's not so interesting.
It seems you're muted now.
No, I'm not muted.
I'm sorry. So I'm going to try to do some affirmative action myself now by promoting one of the questions from the bottom, which is quite interesting. When is it ethical to influence a system to remove bias? And how should we regulate this to determine what's right or wrong?
A very hard question. I'm not an ethicist to answer that, but I will say if a system can harm people, you need to take care about bias. And of course, the solution shouldn't be yours. The solution should come either from society, should come either from like an ethical board. Even you can there are many institutions that have an ethical board, and then you can say, I have this issue. What do you think is the best solution? What do you think is the best policy? And policies for fairness are not easy. Typically, different fairness policies, they clash with each other. So it's almost impossible to basically optimize for more than one fairness policy. So try to check with experts what is the right policy that you need to use.
Great. That was a question, by the way, by Andrea Barazza-Urbina. And now another promoted question from the bottom, which is quite interesting, by Nava Tintarev. How promising do you think new interaction mechanisms are for mitigating consumption click bias, in particular for disputed topics or news?
Yeah, very hard question too. I think Phil would answer that one better because he has worked a lot on that. But I would say if you have disputed issues, I would say that the best solution is not to try to find what is the right one, because, for example, in religion, we will never agree, but we can have different views. So, for example, it would be much better to have all the multiple views, and all the views are available to people to check and decide. So basically, it will be like a referendum. Here you have the 3 views on this topic. We cannot agree on what is the best, but maybe you can choose one of them. And this is sometimes, it's not only the problem of beliefs, where we may disagree, but even in some historical things, we don't have agreement because the history is written in many different ways.
Yeah, another different topic. You mentioned this at the end of your talk as well. This is a question by Sami Kenisi and a related question by Menno Slocum. Would research toward generating benchmark data sets that have biased information, like, for example, exposure data, and also what algorithm was used to create that data? Would this help creating a more reliable evaluation process? And related to that, what do you think the role of synthetic data set generation would be in that case?
No, I think that's a very good idea. There are already some data sets with known bias that are around to do experiments. That if we have like a benchmark, like something standard like check in information retrieval, that will be very interesting. And of course, synthetic data is key there, because in synthetic data we can know exactly the bias that the data has, because we can put the bias there. One problem with that we have today is that if we know the type of bias, it's easy to measure. But if the bias is unknown, it becomes a data mining problem, and it's not trivial. So let's say we have some bias that we don't know of, a new one. How we find that? That's, I think, a very interesting research problem.
Awesome. And one last question. I think you touched upon that as well, but it could be nice to elaborate on top of it. This is by Fernando Benjamin Perez. How can we mitigate echo chambers in recommender systems? For instance, how can we could provide random or least popular recommendations, as you mentioned, but that of course affects revenue. Do you have any idea of how to come up with the appropriate trade-off in this case?
I think you need to do both a bit of random exploration and a bit of targeted exploration. So you always know something about the new things. So it's not like you can find similar items or similar users. So it's not something that is completely new. So you can do some targeted exploration, but I think you should do that in spite of losing revenue, because at some point you will get a stable, and then the revenue will start to grow. So basically you need to do enough exploration at the beginning to know your world better. This is like, okay, I want to know the world. The only way is to basically spend time knowing the world, and after I finish, now I know everything and I will do better. So this is the point. So you need to invest, like we people invested in a PhD, to be able to do long-term revenue. And this is something that I think many systems are not doing because they are stuck on the short-term revenue.
Awesome. Thanks a lot once again for a great talk. I think people appreciated it a lot. There were lots of discussions going on in the forums. If you have some time to look up them and engage with the askers, that would be great. And I would encourage our attendees to join the next social activity during the break now, which is RecSys in India. And see you around. Thank you again, Ricardo.
Thank you. Muito obrigado, Rodrygo.
De nada, foi prazer. Thank you.